Welcome to the first lesson of Module 7. We're going to look at architectural thinking and application patterns. In this lesson, we're shifting from how do I build an agent, which we did in the previous module, to what pattern should I choose. This matters a lot more than code. In modules 5 and 6, you learned components, you learned MCP servers, how to use tools, memory, you learned chaining, and now we're asking the harder question: which architectural pattern fits this problem? Let's look at 5 patterns. The first pattern we're going to look at are knowledge assistants. Simple RAG systems. They retrieve documents, they synthesize answers. Examples are customer support chatbots, internal knowledge bases. What are the strengths of these systems? They're simple, they're stateless, they have predictable costs, and they're easy to evaluate. And what is the trade-off? Limited autonomy and, I will say, shallow reasoning. Let's look at the second pattern, copilots. Now, these sit inside existing apps, such as GitHub in IDE editors like Visual Studio Code. Another example is Slack suggestions. Now, these are non-destructive, they are high trust, and you have an easy integration. The trade-off, however, is that there's a bit of a complex integration, and it's harder to measure impact. A third pattern in design is autonomous agents. These make decisions, they call APIs, they execute workflows. They are high leverage and they probably can work 24/7. The trade-off is that they are really complex to debug. They need human oversight and they are expensive to really get right. A fourth pattern is workflow orchestration. So in workflow orchestration, you would have to create explicit steps. There's usually AI human review, AI executes. You have things like loan approvals or even content moderation. The strength is they are auditable, all right, because it's stepwise, and then they are safe by design and they are easy to modify. The trade-off, however, is that they are less flexible than agents, and you have that workflow overhead. A fifth pattern is when you have hybrid platforms. These basically combine one or more of the previous patterns. So you could have 60% knowledge assistant, you could have 20% of a copilot, and you could have maybe 20% of a workflow. They are really most realistic for serious products. Now, why does choice matter? Is because your architectural choice often cascades. Okay, you could have when you're thinking about complexity, how many components do you actually need? If you're looking at cost, what about model costs? What about infrastructure? What about the cost of human review? In terms of maintainability, how easy is it to change? And then finally, for user experience, how does it feel to the users? In terms of governance, what oversight is actually needed? Now, if we choose, should we choose an autonomous agent? If we do, we're going to inherit debugging challenges, liability questions, and oversight requirements. If we decide to choose the copilot, we'll probably inherit integration complexity, like we mentioned earlier, product dependencies, and measurement challenges. So you have same problem, different implications. Let's look at some real examples. So, for example, GitHub Copilot chose the Copilot pattern. Why? Because developers already trust the editor. So you have high user control. It's fast iteration. There are no autonomous agents. Because that will reduce some level of trust, and there are no knowledge assistants. That would be too simple. So, if we look at, for example, Tesla chose autonomous agent for vehicles. So the real stakes in that, they require massive data sets to, function right. And then you have hardware redundancy. Of course, they have to be legal expertise if there are issues, and then the years and years of iteration. So the architecture reflects the problem domain, that you're trying to solve. So let's look at how does this even connect with the previous two models, that of like the MCP servers and then the agent systems that we talked about earlier. In module 5 and 6, we were taught how to build agents, memory systems, how to call tools, how to do chaining. What this model is trying to do is letting you ask the question, should we even be building an agent at all? It's like matching the pattern to the problem. That is where architectural thinking lives. So let's look at what we're going to be doing through this entire model. In the next lesson, we're going to look at context engineering, which basically is saying, how do we even feed the model, the AI model, or the large language model, the right information? In the third lesson, we're going to look at design patterns. We're going to look at stateless patterns versus stateful patterns. We're going to look at event-driven, and then we're going to look at microservices generally. In the fourth lesson, we're going to look at human in the loop. These are real systems in real life. They are hybrid, and you need to look at how do we architect for such a system. Then in the final lesson, we're going to look at how do we measure if any one of these things are actually working. So by the end of this lesson, you already know, you can describe the 5 major types of AI applications. We've mentioned that already, and then for each one of these types, you understand the trade-offs already. So for example, autonomous agents versus Copilot versus knowledge systems. We will discuss this, and so this you already know. Then you also recognize that these architectural choices shapes complexity, user experience, cost, and even governance requirements. You've also been able to match patterns to business problems by virtue of the examples we gave. And you've also seen that what makes this model stand out, from models 5 and 6, because here we are more focused on architectural decisions. So in closing, I will say that software engineering maturity arrived when we stopped asking, how do I code this, and started asking what architecture is right. Now, AI engineering is at that inflection point now. Building an agent is table stakes. Thinking architecturally, why an agent instead of something else? That's where 10x Engineers lives. Thank you for listening.
Thanks for watching.